Hello, what's up, amazing people, amazing students, all the lovers of chemistry out there. I am super excited to be with you on this all new series that I'm going to be starting and kicking off with this video. We're going to be diving into the concept of acids, bases, and salts. By the way, if you're a lover of chemistry, you study chemistry in your secondary school, and it's giving you one or two problems here and there. That's why this YouTube channel was created for you. My name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. If you're interested in that, please do well to like this video, share, and subscribe as we dive into the concepts of what we have for today. So without wasting time, let's get into what we have for today. So let's start off by defining the basic terminologies in this topic. First of all, acids. What are acids? Now, to the layman, somebody who doesn't study chemistry, he would define an acid to be a substance that tastes sour and can turn blue litmus paper to red, just like we have over here. But in chemistry, we do not define acids like that. In chemistry, we define acids to be a substance that releases hydrogen ions when it is dissolved in water. Here is a simple definition. Acids are substances that give off hydrogen ions. What are hydrogen ions? This is what a hydrogen ion looks like. H with a plus standing above it. So an acid is simply a substance that gives off hydrogen ions when it is dissolved in water. A very good example of the concept of acids is the acid that we call hydrochloric acid, HCl. When you dissolve HCl in water, and water has the formula H2O, one of the things that will be released is hydrogen ions. Every acid has that characteristics. It gives off hydrogen ions when it is dissolved in water. Now that we've defined what acids are, let's move on to the next concept. Here are some relatable examples that you can relate to, and some of the things that you use in everyday life. Lemon juice, for example, that you have over here, contains acid, and that acid is actually called citric acid. You see that family of fruits, lemon, orange, lime, all of them are called citrus fruits. Citrus fruits, and they are called that name because they contain citric acid. That is what makes them sour. And then we have vinegar, on the other hand, that you have in most of your kitchens, used for cooking and also used for cleaning. And this vinegar over here. And then we have the acid in your car batteries, which is over here. Now, the acid in our car batteries contains sulfuric acid. Now, here's just a sneak peek into what sulfuric acid is, H2SO4. We're going to go into more detail as we proceed. So this is one strong and dangerous acid, and it is contained in your car battery. Now, here is an everyday clue. If it tastes sour like lemon, it probably has acid in it. But please note, never taste unknown substances in the laboratory. So here are those are some relatable examples of what acids are, and some of them in our everyday life. Proceed to the next thing. Now we've defined what acids are. Let's go ahead and define what a base is. A base is a substance that feels slippery or soapy and can turn red litmus paper to blue. In the case of acids, we saw that acids turn blue litmus paper red, but over here we can see that bases turn red litmus paper into blue. Now that is what a layman would define a base to be, but in chemistry we define a base to be a substance that releases hydroxide ions. Hydroxide ions is the OH minus ions when it is dissolved in water. A very good example of a base is the popular base called sodium hydroxide. We use this to make soap. Here is a simple definition. Bases give off hydroxide ions when it is dissolved in water. Are there some relatable examples of bases that we can talk about? Of course, and let's see some of them and what they are. Here are some relatable examples of bases that we have in our everyday activities. If you use soap and detergents in your house, maybe for washing clothes, washing plates, I meant to say, they contain bases, and these is one good example. If you use baking soda is actually a base as well, and it's a weak base that is used in cooking. And if you use bleach, maybe to whiten your clothes that are light in color, it is actually a strong base that is used in cleaning. So bases and acids are not just limited to laboratory and factories and all of that. No, they also apply to our everyday lives. Now, here is a clue. If it feels slippery or soapy and doesn't taste sour, it might be a base. Again, no tasting of substances in the laboratories. Now that we have defined what a base is and what an acid is, let's define the last terminology, a salt. What is a salt, or what are salts? First things first, we need to understand that a salt is a substance that is formed when an acid reacts with a base. Here is a very good example. One of the popular bases that we have in chemistry, I said earlier on, is sodium hydroxide. And one of the popular acids we have in chemistry is hydrochloric acid, HCl. Now, when a base reacts with an acid, this is called a neutralization reaction. We're going to come into more detail as we proceed, okay? But whenever a base and an acid reacts, we call it a neutralization reaction. Why? Because they are neutralizing each other. It's just like saying plus and minus. They will neutralize themselves. So now, when an acid and a base reacts, one of the things that is formed is a salt. Salt and water will be formed. Water is H2O, and in this case the salt that is formed is sodium chloride. This is the table salt that we use in our house. So now, salts are formed when an acid reacts with a base. This type of reaction is called neutralization. In the process, the H plus from the acid and the OH minus from the base cancel each other out, forming water and a salt. Now remember, I said earlier on that an acid, when it is dissolved in water, it produces H plus ions, and a base, when it is dissolved in water, produces hydroxide ions. So now, when an acid and a base reacts, the acid produces H plus and the base produces OH minus. When H plus or hydrogen ions react with OH minus, they produce water, H2O. That is why one of the things that is produced when an acid and a base reacts is water and a salt, which we just saw in the previous equation that I just put out. So a simple definition of what salts are. Salts are the results of the reactions that occur between an acid and a base. Now that we have defined what a salt is, let's proceed into the next thing that we have. Are there any relatable examples of what salts are in our everyday life? Of course, there are. And the first and most notable and most relatable example of what a salt is the table salt that we use in our various homes. We use this for cooking, we use this to preserve food, we use salt for all kinds of things in our houses. So from hydrochloric acid, the reaction that occurs between hydrochloric acid and sodium hydroxide, I showed that in the previous slide. Hydrochloric acid is HCl and sodium hydroxide is NaOH. So when this acid and this base react, they produce table salt and water. So that's the first example of what a salt is. The next example that we have is Epsom salt. Epsom salt is used for soaking tired feet. Now, for those of you who do manicure, something we call foot soak. Now, one of the things that is dissolved in the liquid where you soak your feet in is Epsom salt. It helps to detoxify your feet. So that's what Epsom salt is used for. And the third, and one of very relatable example of what a salt is a toothpaste. Now, toothpaste generally is not salt, but it actually contains salt in it. And the kind of salt that is contained in your toothpaste is called the fluoride salt, because toothpaste generally contain a chemical element that is called fluorine. I don't know if I'm spelling it correctly. Fluorine, whether it's this one or this one, basically. So what I'm trying to say is fluoride salt is contained in your toothpaste, and it contains mild salts to help neutralize the acids in the mouth. So now that we've talked about some of the relatable examples of what a salt is, let's talk about the properties or the characteristics of acids and bases. Are there properties of acids and bases? Of course there are. Now let's begin with the physical properties. The physical properties are things that you can observe or feel without causing a chemical change. So for acids, first of all, acids taste sour. Acids taste sour. If you taste a fruit like lemon or vinegar, you would understand that the taste is a bit sour. It slaps. In Nigeria here, we say it used to slap. So the taste of an acid is sour. Now, as far as touch is concerned, the second characteristics of acid is that they can sting or burn the skin. It is actually corrosive. That is the word, corrosive. That is, it burns or it stings. That is one characteristics of acid. So you are advised not to touch them directly. That is why in the chemistry laboratories, you see the bottles that contain acidic substances. There are warnings there that you should not, touch them directly, because they are very dangerous to the touch. Now, concerning the state of matter, most of them are usually liquids or solutions that have been dissolved in water most of the time. And then for litmus tests, every acid turns blue litmus paper red. So from blue, if you place a blue litmus paper in an acid, it changes from blue into red. And the final physical characteristic of an acid is an acid can actually conduct electricity in solution. Why? Because of the free hydrogen ions. Remember, when an acid is dissolved in water, one of the things it produces is hydrogen ions, and because of these ions, it can conduct electricity. So now that we've talked about some of the physical characteristics or properties of an acid, let's move on to the properties or the chemical properties of an acid. Before we do that, let's talk about some of the properties of a base, the physical properties of a base. First of all, bases taste bitter. If you've ever tasted your though it's not something that I advise, if you have ever mistakenly tasted soap, you know that soap is not sweet at all. So here are some examples: unsweetened cocoa powder and baking soda. They don't taste pleasant to the tongue. So bases are bitter in their taste. We're talking about the physical properties. In terms of touch, bases are very, very slippery. That is why your soap feels slippery when it is dissolved in water. If you maybe take a bar of soap and then you pour some water on your hand and you begin to rub it against your hand, you feel that slippery sensation begin to develop. So when it comes to the touch, bases are slippery and they have a soapy feel, like soaps and detergents. In terms of their state of matter, bases can either be solids, for example your washing soda, or they can be in liquids. A very good example is ammonia, and ammonia is NH3. We're coming to that very shortly. And in terms of litmus tests, all bases turn red litmus paper into blue. And then finally, bases can as well conduct electricity, just like their counterparts acid. They also conduct electricity because of the hydroxide free ions in solution. Remember, we say when you dissolve a base in water, one of the things that it produces is the hydroxide ions, and these guys here make it possible for bases to conduct electricity. I'm sure this lesson is being profitable and educational to you. Please, if it is, I'd like you to do me a favor by subscribing, liking this video, and turning on the notification bell icon so when more videos like this come out, you'd be the first to be notified. So ahead, we've talked about the physical properties of acids and of bases. Let's talk about the chemical properties. Beginning with acids. The first thing to note about acids is that acids react with metals to produce salt and hydrogen gas. Acids react with metals to produce salt and hydrogen gas. What this means basically is that when you react an acid A and then you react it with a metal M, what it will produce is salt and hydrogen gas H2. Is there any example? For instance, let's say you have the acid hydrochloric acid HCl and then you react it with a metal sodium. This guy over here, chlorine, and this guy over here, sodium, are going to merge together to form sodium chloride, which is a salt. And then this hydrogen is going to be liberated as hydrogen gas. So let me balance this equation real quickly. We have 2 over here, and over here we also have 2, and then we have 2 over here. So basically what we're saying is when acids react with metals, they produce salt and hydrogen gas. This is why one of the ways through which hydrogen gases are produced on a large scale in industries is that they react them, or they react acids with metals to liberate hydrogen gas. So that's one chemical property of an acid. The next chemical property of acids is that acids react with bases to form salt and water. We saw that earlier on when you react, for example, hydrochloric acid and sodium hydroxide. This is the acid and then this is the base. When the two of them react, what we have is salt, sodium chloride, and water, H2O. So basically acids react with bases to form salt and water. Are there any more chemical properties of acids? We'll hold on right there and then we'll move to bases. So the first chemical properties of bases is that bases react with acids again to form salt and water. So it's more like the same property in both cases. Acids react with bases to form salt and water, and bases react with acids to form salt and water. And when an acid reacts with a base, what we call it is a neutralization reaction, because they are more like neutralizing the effect of each other. It's just like saying +3 and then -3. The two of them are going to cancel each other out to give 0, which is neutral. So that's what the reaction between an acid and a base is all about. It's a neutralization reaction. A base as well reacts with ammonium salt to release ammonium gas. Now, this is ammonium chloride. Ammonium chloride. That's the name of this chemical compound that I just labeled now. And this is a base, sodium hydroxide. When a base reacts with an ammonium salt, what happens is that it releases ammonia gas, and this is ammonia gas, NH3. Alright, so that's one chemical property of a base. It reacts with ammonium salts to release ammonia gas. So that's it for today's video. It's an introductory video into the concept of acids, bases, and salts. We've seen what an acid is, we've seen what a base is, and we've seen what a salt is. We've also talked about the physical and the chemical properties of acids and bases. If this video educated you in any profitable way, I'd like you to please subscribe, like this video, and share it to as many as you can, so we can do more good to as many people as we can reach. Up until I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so Chemi can make history. Till I come your way next time with another video educating you on salts, acids, and base. Stay tuned.